Okay, so we talked about supplementary angles. We said supplementary angles are two angles that add up to be 180 degrees. So what is true about complementary angles? Right, complementary angles add up to be 90 degrees. So let me start by drawing my little right triangle here. So we got to make it a right triangle because the stupid thing doesn't allow us to do right triangles. It only lets us make equilateral triangles. So we're going to make a nice little right triangle here. Hopefully, there we go. Scooch it over a skosh. So there, and we got our ordered pairs because we know those. So this is the ordered pair, cosine theta, sine theta. Get our little Greek letter. Cosine theta, sine theta, and of course this is theta in the center there. So we got that sucker. Okay, so now what we're going to do is we're going to do the complement. Well, here's the deal. If this is theta, right here to here, then the complement is this portion right there. So it's like when we stop short of 90 by theta degrees. So what we're going to do is we're going to take this right triangle here, we're going to copy it, and this time what are we going to do so that it's going to stop short of 90 degrees? How are we going to transform this? We're not going to reflect over x, we're not going to reflect over y. What are we going to reflect over? Let's see if it's even an option. It is not an option. So what we're going to do is we're going to reflect this over the line y equals x. Okay, so let me first draw my line y equals x in. So let me get a line here. Give me a little line, and I'm going to draw my line y equals x. Which means that basically what happens when we reflect over y equals x, if you remember from last chapter when we reflected over y equals x, what happened to our ordered pairs? Right, our ordered pairs switched. So instead of this being, I'm going to make that a different color so it stands out a little bit. So what I'm going to do now is I'm going to take this and I'm going to reflect this over y equals x. So to do that, first I'm going to rotate it, and then I want it to stop kind of like this, and then I'm going to flip it because I want my theta to still be there. Okay, so I got this, and now I'm going to flip that line. I'm going to transform, and I'm going to mirror. Nope, I'm going to flip in the y-axis, and I'm going to bring that back. So there, now my theta is still here, right? So this theta is still right there. So I've got that, and that's theta. So to find the complement of this, my ordered pairs are still cosine theta, sine theta, but how did I get this angle? If that's theta, what is this portion right here? Well, it's going to be 90 minus theta, or pi over 2 minus theta. So this ordered pair up here, it's still going to be cosine, but it's going to be 90 minus theta, or pi minus theta. So to use our complements theorem, what we have to do is think about, okay, what happened here? What happened here when I did this rotation? What happened here when I reflected this over the line y equals x? So in other words, what happened when I had the cosine of 90 degrees minus theta? Well, the cosine of 90 degrees minus theta, when I switch this, instead of this being cosine sine, it's now going to be sine cosine. So that's going to equal the sine of theta, because all we did was switch our x's and y's. Likewise, when we do the sine of the complement, we're going to have the cosine of theta. And we're not going to talk about what the tangent is because we haven't defined that yet. So the complements are when the sine and the cosine switch. Now, think about that, folks. Think about it. If you have a right triangle, okay, any right triangle, and you make your right triangle, right? So here's my right triangle. I'm going to edit my points. I'm going to make it a right triangle. Yes? So here's the deal. So this is A, this is B, this is C. And if this is my angle, right? So say this is theta, and say this is, I don't know, beta. It's kind of confusing with two P's. The sine of theta is opposite divided by hypotenuse. The cosine of beta, which is the complement, is B divided by C. They're the same because they're complementary, because of the relationship within the right triangle. So for those of you that didn't get that, again, let's try it one more time. So if we had a right triangle here, okay, and we said that this angle was A, and this is angle B. This is our right triangle. So there's our right angle. So that means that this is our hypotenuse. Okay? This is our y coordinate. This is our x coordinate. If I ask you for the sine of A, the sine of A would be y divided by the hypotenuse, because it's opposite divided by hypotenuse. Now, A and B plus 90 equals 180 degrees, which means A plus B has to be 90, which means A and B are complementary. So if I ask you for the cosine of B, which is the complement of A, the cosine of B is adjacent divided by hypotenuse, which is y divided by h. And isn't that exactly what the sine was? So those are complementary angles, so the cosine equaled the sine.